Thanks, Racy, for the opportunity. I am Nadezhda Zhivchikova. I represent the Institute of Software Systems of the Russian Academy of Science, a research center for multiprocessor systems. At the same time, I am an employee of internet provider of Pereyaslav-Zalesky. Today, I would like to tell you about our experience of using virtualization technologies in telecommunications. In particular, I'll tell you about using a virtual machine as a router. We have a task. We have a router at the edge between a Botic network and the outside world. At that point, we manage our traffic. We have subscribers. Each subscriber has its class, and the maximum speed is throttled. It depends on the class. By using this class-based system, we provide fair access to all subscribers. In the core, we have the queuing engine. Most of our subscribers use private networks. So we add net as well. As a result, the situation is like this. We receive packets with a private IP address. It goes through NAT, gets a new internal address, and then goes to the queue, to the queue. And we see a problem that actually this subscriber, his class should match his class, but after that, he gets a new address and it doesn't work. How can we solve this problem? We have to classify packets and then only pass them through NAT, and the other way around. The simplest way is to take two routers and divide the functions between them. The first router will classify, the second one will apply new network addresses, and vice versa. What else can we do? We can avoid taking two physical routers. We can take one physical router and the other will be a virtual router, and they will solve the problem. Then, what is the technology, the virtualization technology? In Linux core, in a Linux kernel, we have different engines. We have used Zen and LXC only so far. In our lab, we used the following hardware characteristics. What is important? 4 cores, and network cards were specific. They enabled the core to distribute, to balance load between all the cores evenly. And we have 2 network interfaces. We want to get the performance of 2 gigabits per second. So how did we test all that? We had 2 routers, but they are connected serially, and we can assess and evaluate the overall throughput by taking just one of them. We generate test traffic and measure performance at the interfaces. The first test, I don't know how well you can see them. Test 1 was done on a physical router. We had 5 tests with different parameters, with different packet size. The packet size affects the result to a great extent, and we see that at the maximum size of the packet, we get the maximum throughput, which is comparable to the physical interface. If the packets are small, we cannot get that, but the performance measured in packets per second is the highest of all. These are the results of the tests where we took a physical machine, loaded it, and measured what the machine can do with this interface. That was a sample for further comparison of a virtual machine with a physical one. I told you we used the specialized network cards that would balance the load evenly between all the processor cores. You can see we have 4 cores, and they are loaded almost evenly. Now, let's take another installation with a virtual router. The test is exactly the same. The packets go through a physical R1 interface and through a virtual R2 interface. And what about the performance? The first solution is the Zen-based virtual machine. Even with the largest packets, we cannot reach the maximum performance. So the results are not good at all. However, when we took LXC, we saw the results which were almost the same as in the first place when we tested the physical router. And this is the comparison of the 3 tests. I didn't use the right colors, but the idea is that Zen is no good at all, for us at least. And to compare, we took LXC, which is a bit below. With smaller packets, the results are a little worse. But the bigger the packet is, the closer are the 2 lines, the physical line and the virtual line. These were the lab tests, but actually we had an installation with a virtual router on top of the physical one. We use it in our network at the edge as an edge router. And even in 2 places, in one place for about a year with good results. The second one has just been installed. Real load, real life loading. This is real traffic, production traffic. Before we generated traffic with various packet size, this is real production traffic. So, we had 2 physical servers. We replaced one with a virtual one, and well, we got the same performance, but we saved on hardware 50%. Instead of servicing 2 physical servers, we maintain only 1. We can also think about other benefits as well. This is our experience. Thank you for attention. If you have questions, I would like to answer them. My name is Victor. In slide 1, you showed us a problem with the net. What if we use that, well, the first, this one? Yes. Yes. Why not shift it? Linux kernel is organized in such a way that first net, then queues. If we could change queues first, net second, there would have been no problem, but this is not the case. The second question, what about namespace Linux, which makes it possible to do that without virtualization? This is, well, namespace, you said. Yes, you have to launch one operating system, and that is all with namespace. With LXC also we have one kernel only. Just we took the virtualization technologies which are popular, tried to use several of them, and we solved our problem. We're happy. And in the last slide, I would like to look at your virtual router, where we could use it for backup, migration without stopping the service. Yes, good question. At this point, what do? We have several external channels, and one is out of order. We have dynamic routing, which works in the following way. The faulty channel users are switched over, failover. They are connected to other channels automatically, but quick replacement of a router is also a good idea, but at the moment we do it this way, dynamic rerouting. That's what we use. Thanks. Well, in your charts, 50 megabits, how many users? I cannot say. I don't know how many end users. I just didn't ask. I didn't know how many real users are behind. Megabytes, yeah, megabytes. What about the charts before? I didn't include the charts before the solutions. Our lab tests confirmed what we planned for the real life. Thank you. I have a comment or a wish. Try to download a gigabit. Try to use 10 gigabit, and you will see some interesting results. What kind of? And try IPv6. Why not? We have address space. Just we need the time and the people. We are thinking about it. Thank you. Can you go back to the slide with Zen? Just why do you think the performance is so low? I don't think there are any problems with virtualization of network drivers. The only problem, the only reason, I believe, is the wrong driver in the network. If you use the right driver, Intel driver, then I believe you wouldn't have such a problem. And by default, it uses its own drivers for network devices, and sometimes you have such a problem as a result. Also, it's very strange to see such behavior. What was the driver, actually? IGB with Zen. I wouldn't like to deceive you, but actually we have been thinking about it. And, well, Zen is different. It has two cores, one for the host system, R1, the second one for the guest system, R2. And when packets are moving between these two cores, this connection is not efficient enough. This is our hypothesis. We believe that packets were just copied from one core to the other, and we lost performance at that particular point. Then you also said that you have automatic load balancing if we use the Intel network card and the CPU as appointed. So that was done at the operating system level in Linux. I don't see the screenshots of the IP balance, how the load is balanced between incoming and outgoing. S&P affinity. We didn't include this information because I have very little time span. I didn't have the time to go into technical detail. That's important. That's really important because by default, in default configuration, we use one core. If you have 16-core configuration, you will have one core for incoming and outgoing traffic for all network interface. This is Zen. So we launch the test. Traffic is generated, packets are processed, and we see that idle is the same at all cores. It doesn't mean that, well, we configured affinity to balance the load. I didn't quite get the question.
So if by default it used one core, one kernel, we would see that one core had idle 0 and others. That's why this is a very sensitive issue. What traffic should be processed with which core? So TX, RX, Y, TX of one interface, RX of another interface should be on the same core. Yes, this information is missing. Yes, we would like to know because this is the heart of the matter. And virtualization, it's either the driver or wrong affinity, this core distribution. So your recommendation is to be more attentive about affinity and the driver. Probably the issue is where we set up affinity in the improperly because the in KVM. So using the vendor driver and set up it correctly, there will be no issue. So it will work at the interface speed. Yeah, great. Thank you very much. Thank you very much.
I would like to invite.
Я хотела бы пригласить. So small, yeah. What's the Linux core? The OS? Which OS did you use to test? Linux core? Linux? I cannot tell you the release because at the old cores there will be the GB old driver that cannot show queues. It will show queues, but it cannot work in simultaneous. But you saw in the processor that the queues work. You know, we have another presenter in the program. Let's give the floor to the next one. Thank you.